And then it's my great pleasure today to introduce Emeritus Professor Paul H. Skelton. He has focused on freshwater fishes all his professional life, and he began his career at the Albany Museum in Makanda, Grahamstown, as curator of lower vertebrates. In 1984, he joined the South African Institute for Aquatic Biodiversity, formerly the JLB Smith Institute of Ethology, as curator of freshwater fishes. He was appointed director of the Institute in 1995, a position he held until his retirement in 2011. He has received several awards for his contribution to the field and has served on the IUCN Freshwater Specialist Group. He currently lives in Port Alfred in South Africa. And today in the presentation, Paul will be discussing the recent contributions to our knowledge of fishes, shedding new light on the out-of-sight and out-of-mind group of these vertebrate animals. And just a reminder that the Freshwater Fishes of Southern Africa, a complete guide, will be available at a 15% discount to all our registrants of this talk, available online as well as from the bookstore. We welcome questions and ask that you can post them in the Q&A box while the talk is going on. And after the presentation, we will have a chance to answer those. So without carrying on any longer, Paul, very much looking forward to this, and over to you. Thank you.
Good morning, everybody. Thank you very much for that introduction, Brett. And yes, I wish I was there looking out over the flats like you guys are in Kirstenbosch. You're going to be talking about, or I'm going to be talking about, a group of animals that most of you probably have really thought about, probably seen occasionally if you go to a public aquarium and so forth, but by and large, they are out of sight, out of mind. To give you an idea of what I mean, go to the Kruger Park and cross a river. Do you ever see people talking about fish or highlighting fish? Ever? So, for most people, they are out of sight and out of mind. And as Brett says, I've been involved with freshwater fishes all my life, published the complete guide for the first edition in 1993, and a couple of editions. This is the third one. Later, I've had a chance to reflect and see the changes that have taken place over many years now in our science, in our knowledge, and so forth. In this talk, I'm going to take you on a few little adventures, one of which, and I'm going to focus down in your area, down in the Southwest Cape, because it is an interesting part of the world. I think you'll all agree. So let's start with Kirstenbosch. Let me just go back there if I can. Yes, to Kirstenbosch. Just down the way from where you are. You go into that lovely pass, and there's a little stream or two, and there's Colonel Bird's path, just down from where you are. And if you look at the plaque, you'll see that he built this, he took control of that area in 1811. Very, very interesting and that. But nothing about the little fishes. Are there any fishes there? Have you ever seen? Have you looked into that water? I wonder. Well, there is a species of fish in Kirstenbosch, a freshwater fish. Yes, there's an image of it very close by on that screen. It's called Galaxius. Galaxius zebratus. Zebratus, obviously, it's a zebra-like fish in its coloration. All right, let me just, I'm mixing up a little bit here. So, zebratus, the first guy to collect that was this French consul who was down in the Cape in 1856, 1858. We call him Castel now. He's got a really grand French name, which you can see on the slide there, but don't worry about it. But there's a sketch that I recently saw that this guy did of the little fishes down on Rondebosch Common. Yes, he collected those fishes there down on the common, very close to where you are. Beautiful little sketches, and he made his notes and so forth. So let's see what he said. There's a closer up of it and what those fish look like in practice. So there on the right is the one that I showed you in Kirstenbosch. And incidentally, there's the one on the left, which is named Galaxius, because if you look very closely, and I don't really expect you to see it, but the little pigment on that fish is very small, and it's like a galaxy of stars. And these fishes are rather interesting, and I'm going to take you to their biogeography a little bit later. But both those species were described from the Liesbeek River. That's their type locality. Very interesting. Do they occur? Well, the one on the right, which is that slender little chap, we have not found there in my lifetime. The one on the left, yes, I've found it just below Kirstenbosch, and I've seen it in that little stream just below where you guys are residents. So how's that? There's some little bit of history, and we'll come back to that group a little bit later in the talk. That other little image below the one on the right is the type specimen. So the specimen that Castelnau collected in 1850s is there in the museum in Paris. How's that, people? All right, so as Brett says, there's a new edition of my book coming out shortly. We're going to come down there in 2 weeks' time and launch this book in the Two Oceans Aquarium. And really, for me, this is a fantastic a moment in my life, because it's giving me a chance to give the public what us scientists know about Southern African freshwater fishes. It tries to answer all the questions, and it really is beautifully illustrated. And any questions you might have, you could get the answer there. And by the way, as you see, for those who don't realize that freshwater fishes are by far the most numerous vertebrates in Africa, for example. You thought birds were numerous. They're more numerous in Southern Africa than freshwater fishes. But in Africa, I'm afraid they don't take first place. Freshwater fishes do. Special fishes. People often ask me that question, and there is a technical difference, perhaps. So we would talk about a shoal of fish, but we will talk about different fishes. The difference being that the shoal is of one kind of fish, whereas the picture on the image on the right is of a whole lot of different fishes. So both of them can be used. And it doesn't really matter, does it, whether you talk about fish or fishes in the plural. So what is a fish? Do you know what a fish is? I hope so. You eat them often enough. Well, from a scientific perspective, there are different branches. So we look at, and if you look at, I'm going to bring my pointer, can you see it? Barely, but there are three branches of fishes here. There are three main evolutionary lineages of vertebrates. And we represent this as a dichotomy or dichotomous, as branching diagram. And the first branch of the main stream of these vertebrates were for cartilaginous fishes like sharks and rays and so forth. Then a little bit later in time, there was another branch, the sarcopterygians, which include things like coelacanth, lungfish, and frogs, and birds, and mammals, including us. And then, of course, the other line or lineage is bony fishes. But I said this branch here includes us. So if we talk about fishes as a whole, it means, oh dear, we might be fishes. And that is an interesting scientific perspective. So if I published a paper 50 years ago, I could put that the group that I was seeing were fishes. But nowadays, no editor will accept that. No editor will accept me I'm talking about fishes, if I'm only talking about fish in this branch here and so forth. So there you have it. And there on the right is a relationship diagram of the fishes in the book, Southern African freshwater fishes. You can see quite a diverse group. There's the first branch. We've got a few marine groups represented, including the bull shark that you found in the Breda River, famously. You get the lungfish and so forth in the second branch, and then the rest from eels right through to cichlids and all sorts of other bony fishes, trout and all, bass and so forth are the rest, the bony fishes. So how many freshwater fishes are there in Southern Africa? So when I first published in 1993, there were 222 indigenous species accounted for. We did a second edition when Stroke took over the publication in about 2001, and there were a few more, 228 in that one. But in this new edition, now, 315 species. Wow, what an increase. So you guys can realize that this book is going to give you a whole lot more than the other ones before. But 315 over 222 is a very large increase in the number of species being represented. And the questions then are where and why and how have so many fishes been discovered? Well, a lot of those ones that I'm including in those 315 are still under investigation, being described, but we know as scientists that they exist, and we are confident enough that it's just a matter of time for taxonomists like myself and a few others to get the science done properly. You can't just go out and say it is a new one. You've got to show the evidence for why that's a new one. So that's all in progress. The rings on those graphs are where the major changes are taking place in our thinking. These ones here are more mirrors. I'm not going to show you any more mirrors, but they're very interesting ones. And that increase there was a result of investigations into how those fish communicate. And they communicate using electricity. And so that was very interesting new knowledge. The cyprinids, molecular genetics have come on board here, and we now know, and there are a whole lot of new ones in the Southwest Cape, where I did a PhD and thought I knew it all 30, 40 years ago. Well, I knew what I know now is that I knew little then. And then a few other groups where there have been attention. So there's just the number according to the families and so forth. So the biggest skyscraper by far are these cyprinids. Cyprinids are minnows, yellowfish, conch, those sort of fishes. Very interesting, but they dominate the Southern African fauna by a long way. Then there are things like the breams, cichlids, and so forth. They're pretty high, and these more mirrids are high. But those are in the tropics. The cyprinids, some of them come down to the Southwest Cape. And that's our current understanding on the right of the relationships of those families in a very broad sense of the word. So I have my roots in a group that I studied for my PhD in, and I completed that in 1980, called the red fin minnows. They occur in the Cold Mountains, in the Cape Cold Mountains. And I spent many hours camping up in the Cederberg, diving in the rivers, collecting the fishes and so forth, and then studying them. And one of the outcomes of my study was a relationship diagram based on morphology. The genetics wasn't so strong in those days, and so I focused on the morphology, and I've this is the relationship diagram that I established with about, don't worry about the species, but I show you where they distributed there. And I found one up in the Lesotho. We call it the Maluti minnow, and I've linked it into this group, and I had a problem. What was this minnow doing up there when the group is all down here in these mountains? And I tried to explain that in biogeographical terms by linking the Orange River system in the past with an outlet down in the Olifants River that comes out of the Cederberg. And I published this, and much to my surprise, because there were no published maps of pre-paleo drainage lines or anything like that in southern Africa. This was probably the first that tried to do that. But to my surprise, some of geomorphologists who have been hiding in the bushes because they did not really, I think, enjoy people knowing that the Orange River, where the diamonds are found up there, and the fact that you get diamonds down the coast along here might have been linked by paleo drainage lines. Anyway, whatever it was, this has been vindicated, and the geologists have now agreed that many, many millions of years ago, the upper Orange linked with the Orange. Anyway, that was my then story, and I went in, and since that time, we found some fascinating things about these little redfin minnows, including that they are polyploid. They have twice the number of chromosomes as other cyprinids. They have chromosomes there, which I'm showing you here in the left-hand box, of about 100. Most cyprinids in Africa only have about 50 chromosomes in their cells. Now, that was very interesting. They were polyploid. That explained to me a number of things. Their genetic base allowed the great plasticity that I found compared to other minnows and so forth. They had various features like tubercles, and a postdoc that came and worked with me came into my office one day and said, "Paul, I've been hearing funny sounds in the waters when I dive." And I'm unfortunately hard of hearing, so I don't hear these things, but he found it. And we published the first sound production by minnows in Africa. Never been recorded before, and none have been recorded since. But it looks like these guys talk to each other as well through sound. So very, very interesting knowledge base that we've got emerging from this. And of course, the geneticists have got hold of them as well. And my student, Ernst Schwartz, and his student, Albert Chakona. Albert is currently the acting MD of SIAB, all revisited the redfins, and but through a genetic lens. And they turned my cladogram upside down, I'm sad to say, but they are right and I was wrong. And what we now know is, and this is all you really know, there's quite a few species. There are a lot more species than I realized, but there are two basic groups. There are those with one mouth barbel. There, if you look very, very careful, you can see a barbel there. This one's got it as well. And there's a group here with two barbels on their mouth. This group are those from the Southwest Cape, and I'll return to that a little bit later. So you hear Trudeau, Henningness, Breda, Berg River, Balloon Play, all places down in the Southwest Cape. These ones are the ones further east along the mountains, the Cornwalls, and in the Eastern Cape and so forth. And then there's this one here high in the Lesotho Mountains as well. So we'll come back to that. So my big question was, look at that map, Google Earth map of the Southwest Cape. And there's the escarpment line over there. This is the Tankwa Karoo. And here's the Fold Mountains. Here the Swartlands, where all the wheat is grown and so forth, and the Berg River flows. And there, those fold mountains, the Langeberg going into the Okaniqua Mountains and stretching right across the Swartberg, and here the Hottentot Holland, Riffiesonnerend Mountains and so on. But my question is, that barrier of mountains, how did these fishes get down, right down into the Southwest Cape if they came from the north? Crossing the Tankra Karoo, crossing the Great Karoo, that's quite a job, isn't it? And I'm going to try and answer that question in the rest of this talk. So the first thing I need to bring to your attention, if you don't already realize it, is that water, fresh water, is a living medium. It's the medium for freshwater fishing. But it is a medium that is tied to the land. What do I mean by that? Well, first of all, freshwater fishes can't get up like a bird and fly across the mountain range or fly across the Karoo and just distribute. It's tied to the river. If the river's not there, if the river dries out, the fish dies out. It's as clear as day and night that is it. So fishes are very, very restricted when it comes to dispersal or getting around the globe if you're not in the marine environment, if you're in the freshwater environment. The second thing is the rivers themselves. There's an aerial shot I took from a plane not so long ago of the Kai River. Quite a lovely one because it shows the landscape being sculptured by these rivers. So the landscape and rivers are the heart of that landscape. Everything about it is sculptured by the rivers. And in those rivers are the fishes. And if the rivers change their course or are captured by another river or dry up, all of that affects the evolution of fishes. So, sorry, I'm going to go back to that one slide. So we started to discover our fishes, scientifically speaking, when the British came to the Cape in about 1805, thereabouts. And the first freshwater fishes were described by William Burchell in 1822-23. But by 1880, when Albert Gunther was the keeper of zoology in the British Museum in London, and he published this book called An Introduction to the Study of Fishes, lovely book. And when he was talking about distribution of fishes around the globe and he came to Africa, he concluded that the fishes of Africa, particularly those of Southern Africa, came from the north. And that was about all he could say. So if that is so, then the Southwest Cape is even more significant because it's at the very southern tip of Africa. So we've got to explain how those fishes got there. Now, that little group that I told you that occur in Kirstenbosch rivers and the Cape and so forth, are the Galaxias. Don't worry too much technically about them. They're interesting. Why? Because they are found in southern Africa, southern Australia, the tip of Australia, New Zealand, the All Blacks, of course, and South America and the Falkland Islands. And the obvious, should I say, once you start talking Gondwanaland, is that they are freshwater. Some of them do migrate into marine environments. They're diadromous, as we would say. But by and large, the explanation is, they've been there with the drifting continents. And that's what I thought it was until about 10, 15 years ago, when the geneticists, again, got hold of the group, and they found that the Southern African ones in gold there belonged to a lineage, don't worry too much, but a lineage called the Neochana. There it is there. Neochana are basically one of the strong galactid lineages found here and in the other continents. And of course, now we know this. But the timing that they gave to this, based on these genetic results, was that this Neochana lineage in southern Africa is only at max about 20, 25 million years old. It could not have reached here by being here since Gondwanaland. They have come, as it would now appear to be, through marine dispersal. Because at that point in time, the African continent collided with Eurasia and closed the tropical circulation, and the southern circulation in the oceans opened up through the Drake Passage here. And after that, this particular group must have arrived in southern Africa and in the southern tip where you guys exist and I exist here through the ocean. So that one was not from the north, it was from the south. The other little group is a group of little catfishes. There's 10 of them, okay, in that we know of, and we're pretty sure about, and so forth. So when I finished my PhD, I'd been exploring the rivers, the Olifants River in the Cederberg, and I'd come across a species there. But I also noticed that there was they weren't all the same, and I investigated it and described a species called Ostroglanus barnardi. Now, if you look there, all three of the known species, the two in the Olifant and the one in the Orange River system, Platera, Gilla, and Barnardi. Those are all old South African museums, now Ezekiel Museum, but South African museums, when those guys were there, directors of that museum. That's an interesting one, a taxonomic one. The interesting thing for me was that when I looked at the bone structures, the osteology of these animals, I couldn't place them with any African species. They were different. They just did not fit in. And for many, many years, this group, this genus, and as we once knew it, now a family of fishes with just 3 species in it, we had no idea where they were related. 2 years ago, some colleagues published a genetic study again and showed that these fishes, here is a study I'm going to show you, there it is, were related to a group of catfishes, the Ictolurids, that red dot there, North America. What are they doing in Trumpland? The Cranoglannids from Asia, the Pangaseas from India, and then Ostroglannids from South Africa. How the heck do you connect those fishes together? Well, the link was their out-group relatives, this one here, the Ariid marine catfishes. How interesting is that? So all of these had a marine, at their very base, they were probably linked to that marine origin. And that their source, and again, the timing that the genetics allows the scientists to put, was that they were very early, paleogenic. We're talking about 55, 60 million years ago. At that time, remember when I told you the upper orange was linked to the Olifants? Well, this group of fishes is probably the only group that actually demonstrates or reflects that particular linkage. How's that? There are only 3. They're not particularly well known. They're highly threatened. But look what they represent. They represent a phase of Earth that no other vertebrates, no birds, none of those things, but these vertebrates, these fishes, tell us and reflect our paleogeomorphology and history in this land is part of it. Oh, let's get back to the real thing, eh? The giant redfin. Pseudobarbus, Skelton eye. Oh boy, there we go. So my colleagues thought I was Mr. Red, and they decided to name this rather rare, but rather interesting species after me. And it's found in the upper Rufus-Sonorent, two little tributaries there, and it must have been more widespread than that because it's also found in a branch of the Smallbone, which is a branch of the mainstream Freedom River. So it's a red flag. Now let's look at these red flags again. There they are down here. What we have since found in the years since I published my cladograms of just this group down here is that they are related to a whole lot of other groups here, which are now genera of their own. Those colors represent genera. Chilobarbus, Amatola-cypris, Pseudobarbus, and Namaquacypris. And if we look at their distribution, look at it there. Namaquacypris really below Ochrabi's Falls. Amatola-cypris only in the Amatola mountain rivers. These two down in the Southwest Cape, that's Chilobarbus, they're the Vitpus, and the Sorpin. The Vitpus is one of the rarest now. And then these two, Pseudocypris. That was this one here, Pseudocypris erubescens, from only the Tweer River tributary in the Ulipan, the first fish I described in my career. Very interesting. But look at their distribution in the map. There's a big gap right in the interior. How do you link the bottom half of the Ori, the top half, and then the Cape Fold Mountains? What happened? There has to be red fins in that phase at some stage or other. Well, climate change, that's part of our current thinking, isn't it? So if we look at effective temperature today, this is a map of effective temperature. It is an actual temperature, but it's a calculated temperature that shows the beginning and the end of the growing season of summer, from about October till about April, May time. It's the effective temperature from a biodistribution perspective. And the purple represents increasingly cold. So the very darkest there, right at the top of the mountain, effective temperature at this time is very cool, okay? And you can deduce. That's the temperature map of Southern Africa. And it reflects the altitude, and you can see the gap, the Karoo, you can see the escarpment, you can see the Cape Fold Mountains where you get snow and all sorts of things on that effective temperature map. Beautifully done for me by Nick Riversmoor. And I asked Nick to just model me what it might have been like in the last glacial maximum, about -6 degrees cooler than it is today. And this is what he came out with. And at that time, the geomorphologists and the geogeographers, the paleogeographers, tell me that there was probably periglacial. There was probably permanent ice up there in the high Drakensberg and places like that. Very, very, very cold, particularly if you're a vertebrate and these freshwater fishes. So it's likely that extremes like this, which happened in fairly recent times, but over a longer period of time, more than once, that there has been fish extinction. And it's my idea and belief that big gap between the top and the bottom of the fish of certain times were eliminated by climate change, by cold climate. But there, just look at that group, and I'm just going to show you very quickly. The one that you find down in the desert channel, Look at its morphology, very different. He's got his fins all far back, he's silvery, he's got no color because it's turbid water, and he knows how to swim in a channel without sitting. The one on the top, Maluti minnow, very different. He's long and supple, very small scale. He lives in tiny streams, in rocks and so forth. And it's a question of those are the only two who have survived the passage of time in what was the faunal arena. The rest of them have gone over the escarpment and taken refuge in the Cape Fold Mountains. So there's that story. There's what that probably happened because, again, the geneticists, we now know when these divergences happened, probably around in the Miocene gap, what I call the Miocene. Miocene time, anything between 10 and about 20 million years ago. There was a big gap and a dichotomy between those with two marbles in the green down here and those with one marble over there. Now, how do we explain that? That's what I'm going to try and tell you about. This diagram is just a simplified one of that, showing the two groups in an inverted way with that division between them. Something happened to separate those two, and it was probably an extinction. So another group reflects a very similar story. So these are the Cape Kerper over here and Sandelia bainesii found there. These are anabantids. Anabantids, apart from these two, are tropical. The Sandelias reflect that origin because they have air-breathing chambers above their gills. The ones in the tropics, in which these are related, actually have air-breathing organs. Because it's colder down here, these guys have lost that. But there are two groups. There's this one, bainesii, Amatola Mountains again, and the Cape Kerper. Now we know there are three species. This is a recent study. Don't worry too much. But we know that there are at least three species. The blue one on the west coast. There's the red one in the Klein River, going down to Hermanus, and the south coast. These are still being described and being worked on as I talk and so forth. But look at that. The pattern is exactly the same or very similar to the red fins, except they don't occur in the orange where they must have. And look at the timing, 25 million years between that gap there. And these ones here, at least 10 million years. Million years I'm talking about, people. That's a long period. So the original split was probably, again, in the Orange River system, between the upland and the basal groups there. And then they all retreated over the escarpment. Through scarp retreat, the rivers are cutting back into the escarpment, capturing as they go along the interior. But that's how they got there. And these are now Cape Fold relic species, and the bainesii are an Amatola relic species. The extinction gap is the big thing. I've got a little diagram here, and I'm going to just go through this very, very quickly. But it shows the geomorphology of the Amatola Mountains and the rivers draining it. And if you know it well, there's a ridge in the middle of the Great Fish River called the Great Fish Runt, as they say in Afrikaans. And then you get the Cape Fold Mountain coming. There's old Grahamstown, Makanda, as we now know. It's the last of the Cape Fold Mountains. Oh, that's where Castell now collected and described Sandelia bainesii from. The Cowie, what's it doing down there? Well, if you look at that river, it was once part of the Great Fish. The rest of the distribution is the Great Fish River, the Cat and the Koornap, and then the Keiskamma and the Buffalo going down to East London. The interesting thing for me is there is no Sandelia in the rest of the great fish going into the Craddock Valley, Middleburg, and so forth. And this particular thing represents a capture there. And the capture, the geomorphologists tell us, there was uplift along this part of the coast. And there's an axis of uplift comes to the Cat Valley. And the rivers here are deeply entrenched. If you go to Bedford over there, it looks like the Highveld. It's flat as a pancake. But go down across the Queen's Highway here, and you're going to entrenched deep valleys. Geomorphology and the landscape, like you have nothing. It's really just marvelous. Again, reflecting millions of years of vertebrate and landscape connection. Right, I'm going to now end my talk with trying to give you what happened down in the Southwest Cape. So in this part of the world, down here and here, you get the Sandelias in that green patch there. You get the two marble redfin complex. It's not as widespread as the Sandelias. You don't get it on the peninsula. It's more or less restricted to the Berg River, Easter River formerly, and the Breda River, and again restricted to the Plain and the Herningness and those sort of rivers there. Then there's another group here, the Witvis and Serra, and the Witvis is found in the Berg and the Breda. So we've got an association of fishes not further abroad than the Cape Fold Mountains, restricted by them down there. How did that happen? Well, the secret, of course, is what we call, there you are, Barnard's Gate. So that's a view looking down on Worcester Valley, the Breda River Valley, and the Hex River Valley there. Okay, it goes up through there. And this is where I'm going to focus our discussion for the next day. What I'm going to call Barnard's Gate. There it is on a map again, and in which I've drawn imaginary paleo lineages of where the rivers once flowed over the landscape before a capture took place at Barnard's Gate that link the interior rivers to the Breda. And of course, we know that the Berg captured the upper Breda through the Little Berg Tooth there near the town where it has the thing, escapes my mind, but it's in the Breda River Valley at the top there. So there's a link over there, and there's a link here, and there's another link in the Ceres Valley as well. So let me try and explain that as Barnard did. Keppel Barnard was a very, very smart biologist and director of the South African Museum. He studied insects, he studied invertebrates, and he studied freshwater fishes and marine fishes and a whole lot of it with authority. He was a marvelous guy. And he was a mountaineer to boot. And when he climbed these mountains, he found at the top of them flightless beetles called colophon. And he was the president of the Geographical Society, and in his address in 1936, he spoke about this particular phenomenon where he found different flightless beetles on top of different mountains. And he tried to explain it by going back and saying at one stage, those mountains were all connected. So the flightless beetles could, move between the mountains. But something happened that divided them up. And what it was river valleys separating. And here he said, in the past, these rivers all drained into this prehistoric river going down, which was one part of the broader river system. And then when they were captured and the rivers broke through the mountains, they reversed those drainages. Now the Hex River flowing down into the earth. So there it is on the map. There you get the current Hex River going down into the Breda. There's Barnard's Gate. There's the During. And the landscape says Barnard was right. He didn't have the luxury of Google Earth, of satellite images or anything like that. But he was a smart guy and he worked it out. There's the Ceres Valley. That was a capture. And there's the little berg being captured by the bird river. So that helps us explain a lot of things. Once they were down into those areas, we also know that climate change affects sea levels. And particularly in the more recent, the last 1 to 2 million years, there's been severe climate fluctuations and sea levels. And the offshore geologists have produced beautiful maps recently showing that the actual sediments of the Agulhas Plain and off there reflect the old river valleys, because rivers bring sediment, particular sediment. And they show that, for example, the Breede River and the Soak River and the Cape Agulhas rivers were all once, the Breede River swung round to this part of to the western part of the Agulhas Plain, and the others did. And the freshwater fish reflect that. How interesting is that, once again? So I need to conclude at this stage. I hope you've enjoyed what I've tried to tell you in a rush, in a nutshell, but it's a fascinating science to be involved in, because it brings in everything: genetics, geography, all these sort of things, and they tell a story like no other group can possibly tell you. So freshwater fishes are tied to the landscape. The landscape tells the story. Our freshwater fishes are a treasure and a rich heritage. And I believe caring and conserving that heritage is not a luxury. If we are true to ourselves, it's an obligation. So conservation and conserving these species that tell the story is something we should elevate as high as we possibly can. Thank you very much. I've enjoyed being able to talk to you at this particular talk. Thank you to Straight, to you, Brett, and your group. It's been wonderful. Thank you very, very much.
Thank you, Paul. That's fantastic. And it just shows that there's that much connected to a particularly small region of South Africa, let alone Southern Africa. The diversity and the interest is huge just across the complete Southern African landscape. And I'm sure that's where the majority of the information we can get in your book would come from. As we'd said previously, if we'd like to post any questions, we will have a question and answer session with Prof. Paul now. Prof, I was wondering, we've had quite a bit of information about the geology and the history and past and how that shapes our fish. How old are our fishes? Do we have an understanding of when they started? And
yeah, thanks, Brett. It's very interesting because age is very important in terms of, just like I said, when I put out that little map and showed the link between the orange and the olifant, I was wrong, except I was out by about 30, 40 million years. That's all. So the fishes that I was trying to explain weren't even in the rivers in that time. So how old are our fishes? Breed ages. The oldest, as I said, is probably Austroglanus, the oldest freshwater fish. And that lineage, we can trace back now to round about 50, 60 million years old. Million years old. That's when, just after the dinosaurs were extinct. It's an incredible passage of time and age for any vertebrate. So there was nothing like the modern mammals or birds or things like that in existence at that time. And they reflect this earth. So that's the oldest. The rest of them, freshwater fishes that we find in southern Africa, apart from the lungfish. Now the lungfish lineage, not the species. Remember, I'm talking lineages. Go back to Gondwana time. And they occur in our tropical reaches, and they are very, very ancient. There are a couple of other groups that reflect that Gondwanaid early period. So we're talking anything up to 80-odd million years of lineage are the Mormerids, those electric fishes I spoke about, and then some little Nereids, but they are also very small. You find them in the top of the mountains up in Angola and in Mpumalanga. There's a relic species and so forth. Those ones are, the lineages go back something like 70 million, 80 million years. But the rest of them are post-Miocene, or when Africa collided with Eurasia, round about 20 to about 30 million years is our best estimates of this period.
Oh, fantastic. Thanks for answering that. Claire has a question here. She says, Claire Keaton says, she's a journalist with the Times Live. Thank you for the talk. As someone who knows nothing about fish, can you comment on what the biodiversity of Southern African fishes is like compared to other regions? And are there any real threats to the survival of our freshwater fish?
Yes, well, thank you for that. That's a good question. So Africa is like a big peninsula into the sea. It is a big peninsula into the sea, but a very big one. If you look at Southern Africa, so I've told you we're talking in the region of 300, 320 odd species in all our rivers, and that is from the Kunene, Zambezi southward. It's by far one of the poorer areas. Why? Because it's so far south. And it's much more difficult for a lot of the freshwater fishes. The richest region is the Congo Basin. Congo Basin is very, very rich. There's probably around 800-900 described species. And as things go, I wouldn't put it that it wouldn't push beyond 1,000 species. Some of the Great Lakes, there's been radiation of species, and in Lake Victoria, there were up to 200 or 300 cichlid species in those lakes. The West Africa is a rich region. The Nile has probably 100, 150 species in alone. So in Africa, it's fairly depauperate down here, fairly depauperate. But in the rest of the world, if you really want to get rich freshwater fishes, go to Southeast Asia, go to the Amazon, the Amazon itself, which is a tropical, once again, very diverse, very complex in its formation and so forth, and a lot of opportunity for freshwater fish radiation. Let me just say this one, it's quite interesting. So freshwaters occupy something around 1 or 2% of the water on the planet. And the marine side is, of course, about 95, 97% of the water. The number of fishes in that small percentage of fresh water is something like 43% of the total fishes on the planet. So it's disproportionate numbers in fresh water because of it's been broken up into tributaries, into lakes, into above waterfalls, below waterfalls, and things like that. And the marine fishes are, in many ways, much more connected. And so there are relatively few. There are more fishes than all other vertebrates on the planet. So it's a relative term. We're talking 35, 40,000 species of fishes in all.
Okay.
Of which 16, 17, 18,000 are in fresh water. Yeah.
And then specific threats to our Southern Africans, like anything specific that we should be aware of?
Thank you. That it's a very important question, and it's very much a threat. But when we come down to roots and to causes and ultimate, it's rooted in human population. The human population is it's exceeded the carrying capacity of the land by a long, long way. So the scientists estimate that the Earth's carrying capacity for human beings is, of the order 1-2 billion people. There are now 8 odd billion people on the planet, way beyond the Earth's carrying capacity, and we're using our intelligence, our science, and everything else to keep us going, and we're using up and exploiting spaces and so on. What happened in the last couple of 100 years with human people is we've got very smart. We can go to the moon, we can do all sorts of things. Before that, say before 1800, we would have to dig a ditch with a spade. Today, we just come along with one machine, and one guy can dig a ditch that, would have taken people a lot. We build dams, we build roads, we build cities. Look at our city. Just look at Cape Town. Look at the expansion of Cape Town and the distraction in that expansion of landscape, of places. We pollute our rivers and so forth. So a lot of the threats are rooted in human population growth and so forth. Here is something I'm going to say that it comes with this talk. Ignorance. Human ignorance on what we are doing to the natural world is one of the greatest threats, in my view. Now, that's an indirect threat in a way, but just as I'm telling you these nice stories, most of you don't know them. Most of us don't know them. Even I, am only working these sort of things out now. So ignorance is another one. When we don't know something, we can't love it. When we don't know it, we don't know what we're destroying in front of our eyes, and so forth. So ignorance is another one. With human population growth, water demand and water engineering is huge. We're moving water around, we're using it. We look at our farms. Irrigation is critical. Look at Cape Town a few years ago when it went dry. Our water was critical. So water, the use of water, the problem with that use is we ignore that it's a living medium. We think it's just a resource. And so we put it in taps and we do all that. Yes, that's important. I'm not for a minute saying it's not. But we ignore that for every drop we take out, we are taking out a drop of living medium for organisms that live in that water. So that is another one there. And then the way we treat water. Come on, people. I can show you pictures. I went to a luxury suburb, let's say in Gauteng recently with my family, and they were playing paddle, bat and everything, and I went down to look at the local river in a luxury suburb. And it was an absolute disgrace. Go down to your Leesbeek, go down to the bottom end of Leesbeek and walk along the canalized Leesbeek. And it's a disgrace. I'm sorry, it's polluted. That's how we treat it. That we use it to destroy waste, and yet it's the most valuable resource. Those are the dangers. Those are the things. And then aliens, yes, aliens. That's another story, and it becomes a bit heated when you start talking trout and bass and so on. Why? Because they're vested interest, and vested interest is probably one of the greatest threats to the conservation of it and the resource itself. I hope that tries to answer a very complex question. Yeah.
I think it's fair that there is no one answer, and then you put all of those factors together, and it becomes a Pandora's box of complications. But thank you for your insight into that. Stefan Fick has a question here. The genus, he's going to make me try and understand. The genus Entromenius, not inside the South African Cape. The temperation stopping its migration to the south. So I think he's asking, the genus of Enteromenius is not inside the South African Cape. Is there a reason, or what is stopping its migration to the south?
Yes. Basically time. When I say that particular group came into Southern Africa, entered into Southern Africa after what became the tetraploid group that I spoke about. So it's a time factor, and yes, they have distributed, they over the escarpment, they're in the Olifant River system, that group is in the Chorus River system, and into the Karoo rivers and the Orange and things like that. But what's stopping them is that those river captures that I spoke about happened before they were in the rivers. And they no longer capturing the river systems for recent times are set as they are. And apart from when people connect them with pipelines and that sort of thing. But that's the basic reason why Enterone is in the Chorus, but it's not in the Southwest Cape, and it's not in the coastal, beyond the coastal ranges of the Fold Mountains.
There we go. Asked and answered. Amber Wilson, hi, Prof. Skelton. It was briefly mentioned that ascalateri ostology is very different. What are some of the main differences one should look out for when identifying them?
Oh, well, those particular catlets are easily identified in Southern Africa where they occur, in the Orange River or in the Olifant River. First of all, they're not the only one, but the other one is a fish called Clarius garipanus, which is a famous one, Platycorp, or the barbel. Afrikaans people refer to it as barbel. We don't, in English, we call it the sharp-toothed catfish. It's very distinct. It's got a very much bigger head, much broader, much flatter, and it doesn't have spine. So the Austroglanus, they only grow up to, trying to show you my fingers, up to, they're small catlets. They're not very big. And they have spines in their dorsal fin and in their pectoral fin, very sharp and so forth. Whereas Clarius only has little spines in its pectoral fins. No, and it's a long, sinuous one. So it's very easy to tell. The osteology is very distinct because it's really quite primitive. Now, that's a complex subject, and I would have to go into diagrams and all sorts of things like that to explain that.
Okay, thank you. I hope that helps, Amber. Pule here has asked very interesting information on the Sandelia lineage. What could be the possible explanation for the distinct distribution of the African Anabantus?
Yes, so there's a big gap between Sandelia and the tropical one. The nearest ones we've got are in KZN, up in Maputo, as they call it, Lake Sabaya, around there. There are two species that you find. The one in a genus called Tinapoma, the air-breathing anabantids, and that's widespread mainly in what we call Low Africa being Congo and West Africa. And this one species called Tinapoma multispiny in our part of the world. Very interesting one. He can walk on land, he can breathe, he's a toughie. The locals believe he comes with the rains because he comes out of the sky because he can walk over land, and particularly during wet periods. The Microtinapoma is a small one, and there are a few of them also in the very similar distribution, but they're tropical. The rest of the anabantids are Asian, okay? Anabas, the climbing perch of India. And the interesting thing about that is that they found a fossil anabantid in high Tibet, in the Himalayas. And that was, as India collided with Asia, it forced up the Himalayas. And the fossil was an aging, was very useful in aging that particular lineage because it went up with the rocks to High Tibet. No anabantids ever recorded there except in that particular way. So very nice story. And it also linked that they arrived in Africa only once Africa started closing that gap on what they call the Tethyan Sea between Africa and Asia around 40 million years ago. So they've been in Africa for a little bit longer than most other people. And that allowed them, the Sandelia plant, to come down with those very early cyprinids in Africa, this Miliogastrians that turned into the tetraploid. And I'll just say this, I'm busy with an American, Chinese-American scientist. He's a postdoc in Florida. That one diagram I showed you has yet unpublished. And he's been working on the evolution of this particular group. And it's really incredible stuff for a scientist like me who started my career studying this, and to see what we now know and what is emerging from real science, and it's across the globe, and that's the beauty of science. We're a global community of people. Yeah.
Totally fascinating. Yeah. Henny Fulyun has asked you, thank you for sharing your knowledge, Prof. I need some help with identifying a fish species found in the Komati River in Mpumalanga. Who could I contact with this in this regard? And I have photos that I can share. What would be his best? Yes. What would be his best protocol?
Okay, so there's a very active group involved at the University of Mpumalanga. Is Professor Gordon O'Brien and Professor Dan Parker. But Professor Gordon O'Brien at the University of Mpumalanga in what was Nelspruit, now Mbombela, and they would be able to help you with Komati River fishing.
There we go, Henny. Thank you for that. And then last question here from Claire has asked, why do you love fish?
Oh. Oh, aren't they beautiful? Aren't they just the most? Have you seen their colors? I didn't show you any pretty fishes because people sometimes say, what's your favorite fish? But you know what? That's an impossible question to answer. They all are. Is, of course, I've got a particular friend. But, yeah, why do I love fish? I think, I fell into it. I was trained into this science. I met my main mentor, and I've had a couple of very good mentors over the years. But the granddaddy of them all was a guy called Rex Jubb. And Rex Jubb was, when I was an honours student, he had just been given an honorary doctorate at Rhodes University and was coming in frequently into the zoo department. And I got to know him around the tea table, and we'd discuss and so on. And he had just so many fascinating stories about freshwater fishes that I couldn't resist. And when the day I walked into the Albany Museum, I knew this was my career. I just came home, I'd landed in the lap of where I wanted to be. And it's difficult to say because I always wanted to be a zoologist, a vertebrate, birds, mammals, yes, of course, Rob, not so much. If you said to me fish before that, I would have sneezed, and most people do, but it's a fascinating world. Once you're in it, ichthyologists they're crazy. They are just, when I say crazy, there's only one world. And all they want to talk about and do and be and whatnot are fishes. And they're just fascinating in their diversity, in their everything. And I guess I'm one of those crazies.
Oh, well, Prof, to say that we are privileged and grateful for you to share your time, to share your clear passion and your unbelievable knowledge. We thank you so much for taking your time to talk to us. Thank you to all of our guests. Thank you to our sponsors. We wish you well for the rest of the week and for October, and bring on spring in the Southern Hemisphere. And we look forward to seeing you all in a month's time for our next Wednesday talk. Thank you to Belinda behind the scenes. And once again, thank you, Prof, for sharing your time and your knowledge and your passion with us. It's been fantastic. Thank you so much. Goodbye, everybody. Keep well. We'll see you in a month's time.